We're taught from grade school that water follows a strict set of rules. At 100 degrees Celsius, it boils. At 0, it freezes. They are opposites, two ends of a spectrum that should never meet. But what if I told you that under the right conditions, water enters a state of total identity crisis? A state where it's so confused, it decides to be a solid, a liquid, and a gas, all at the exact same time. This isn't a camera trick or a simulation. This is the triple point, and it challenges everything you think you know about the most common substance on Earth. To understand this, we have to look past temperature. We usually think water boils because it gets hot, but boiling is actually a tug of war between the energy of water molecules and the pressure of the air above them. Think of the air around you as a heavy lid, pressing down on the water, keeping the molecules trapped. To boil, those molecules need enough energy to push that lid off and escape. Now, what happens if you lift the lid? If you put water inside a vacuum chamber and start sucking the air out, you remove that pressure. The molecules don't need nearly as much heat to escape. In a near-perfect vacuum, water can boil at room temperature. It can even boil at the temperature of an ice cube. And this is where the paradox begins. As the vacuum pump starts, the pressure drops. Suddenly, the water begins to bubble. It looks like it's getting hot, but it's actually getting colder. This is evaporative cooling. The fastest, most energetic molecules are the first to jump out of the liquid and become gas. As they leave, they take their energy with them, leaving the remaining water colder and colder. The water is boiling so fast, it's literally chilling itself to death. And then it happens. The water loses enough heat to freeze. You're looking at a physical stalemate, a boiling liquid creating a freezing solid while giving off a rising vapor, all in a perfect, shaky equilibrium. This isn't just a cool lab trick. This single, precise point, at exactly 0.01 degrees Celsius and about 0.6% of normal air pressure, is so reliable, so fundamental, that for decades it was the literal definition of the Kelvin, the absolute scale of temperature used by every scientist on the planet. And it's not just for labs. If you've ever had freeze-dried food, you've experienced its effects. By dropping the pressure below the triple point, companies turn ice directly into vapor, a process called sublimation that preserves food perfectly. We often see the world in binaries, hot or cold, solid or liquid, but at the triple point, water shows us that the most fundamental rules can blur if you just change the perspective. So the next time you look at a glass of water, remember, it's only a few small adjustments away from doing the impossible. Physics doesn't break the rules, it just shows us how deep the rules actually go.